Hello guys, this is Sri. So in this video, I am trying to explain the MySQL InnoDB architecture. So it will be like how the transaction flow. For example, this is the update statement. And when you are executing this update statement, what happens internally? So by seeing that, we are trying to cover the InnoDB internal architecture on this video. Okay. So yeah, so before going to the topic, we already have few videos related to the InnoDB architecture. So the plan was to create multiple videos to explain the undo logs separately in detail and redo logs separately in detail, and the temporary table spaces, all the components individually in detail. So that I will keep do that. So I think already we have explained the buffer pool and I think undo log as well as we created one detailed video explaining the temporary table spaces, IB-tempon and the IBT files. So this video is about the explaining the this uh, diagram from the official MySQL document, documentation dev.mysql.com. Okay, so I am going to use this diagram from the website. I am referring this diagram in this video. I will try to explain, and I will also use the terminal to show some files and some informations from the InnoDB status, engine InnoDB status output. So hopefully, yeah, I will, yeah, based on my understanding, I am trying to deliver this topic. Okay. Yeah. So before going to the topic, I am also taking the MySQL courses. If anyone is interested, you can reach me for that. Okay. Fine. So, first of all, so you may aware that we have the yeah, so let me come to one by one. So we are updating the table T1, right? So when we so from MySQL before we had the IB data one system table space file. There we store the data for all the tables, table data plus index. Everything will be reside on the same single file, IB data one system table space, right? But laterly, when the MySQL later versions one by one, we are splitting the uh, uh, different components from the IB data one. For example, previously we had the table data, which means the data plus index, as well as undo logs and the change buffer, data dictionary. This all things will be resided in the single file, IB data one, right? Then we had the parameter InnoDB underscore file underscore table. So when we set that equal to on, then the new tables, whatever tables we are creating, that will have their own table space, which means if I am InnoDB file per table equal to on, then if I am creating the table T1, then that table T1 will have its own table space that is called the .ibd file, right? So all the data for that particular table will be stored in the .ibd file, right? Fine. Yeah, so I'm not going to in depth on this IB data one here. So just want to explain here this IBD file. So whenever we have the table, that will have its own IBD table space file, and the table space will have the data plus index for that particular table. Okay, fine. Now, here my update statement, which we are going to see in this video is T1. I am updating the T1 table. I'm just changing the name value from one value to another value where ID equal to 101. Okay, let's assume I logged in the MySQL, and I am going to execute this statement. For example, show tables. Here you can see I have T1, show create table T1. Okay, so you can see I have three columns: ID, name, and CDate. So for the name column, I have the secondary index, and for the ID column, it is the primary key. Okay, for the name column, I have the secondary index. Okay, so here let me execute this update. I am just starting the transaction with begin. MySQL is auto commit. So if you want to manually start the transaction, we need to give begin. And inside that, you can write the SQL statement. After, at the end, you can roll back or commit. Right? Fine. So now I just started one transaction manually with begin, and I ran one update statement. But I did not committed this statement, and I did not rolled back. Okay. I may commit or I may roll back. Okay. So if I am committing this data, then this newer value, set name equal to II, this newer value should be updated at the end, because MySQL supports ACID, right? At the end, my newer value should be II. But if I am rollbacking this statement, then the previous value should be there. So let me check the previous value in the another session. MySQL select star from Sri. Sorry, T1. So you can see for the ID equal to 101, my previous values is B, 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 B. Okay, fine. So now if I run the commit, then this should be there. But if I am rollbacking this statement, like rollback, if I am just rollbacking this statement, then this value should be there because I did not committed this value, right? So MySQL, then how MySQL will track these changes? Because MySQL do not aware whether I am going to commit or rollback, right? So if I am committing, then this new value should be there. If I am rollbacking, then the old value should be there. Then MySQL should have the track of it. MySQL should track the older value, right? So in that case only, if I am rollbacking, MySQL can put the older value. MySQL should aware of the older value so that it can make it the older value in case I am rollbacking the transaction, right? So this information will be stored in the undo log. Okay, this information will be stored in the undo log. Now, just keep this, and before this undo log, I am running the transaction to update where ID equal to 101 on the table T1. Okay, so we know that MySQL have the buffer pool. All the operations should be happens in the buffer pool. Buffer pool is the volatile memory. Okay, buffer pool is the volatile memory, which means we are assigning some memory from the RAM system RAM. It is the volatile memory. Okay, fine. So volatile means whenever the system restart happens, you will lose the data which is written in the volatile. Okay, fine. So here, when I'm just updating this, running this update statement, first MySQL will check. We are going to update this value where ID equal to 101. First, MySQL will check this data, this particular row is available in the buffer pool already or not. So MySQL in the buffer pool, you can see these are all the pages. These are all the squares or the pages. So in MySQL, the default page size is 16 KB. You can get it from this parameter. Select at that InnoDB page size. So this is by in the bytes, you can just convert to 1024. That is the to kilobyte. This is 16 kilobyte KB. Okay. So yeah, 16 KB is mostly helpful on the different environments. So we have the default value 16 KB, and also in the documentation says like for the recent disk drivers, we have the uh, recent SSDs and the RAID disks. We have the block size of 4K. So having the page size to the as close to the disk block size will be helpful to the performance. Okay, but yeah, to be honest, I did not explore much on this parameter. But yeah, in case if you want to make changes of this, then yeah, you should make this change while you are initiating the MySQL. And yeah, I would also recommend to do few checks, some benchmarks with the different block size. Then you can decide different page size, then you can decide the right value for your environment. Okay, fine. So we have this, coming back to the topic, we have this IBD file for the table, and this is the table space. Within this table space, we have lot of pages, and in the pages we have segments, extent, that sectors, that is different. Here, for the table space have lot of pages. Okay, let's assume that book. In the book, we have a lot of pages, and within the page, we have a lot of rows, different thing, right? So just assume it is a table space. We have multiple pages, and let me come to this diagram. So we are updating the T1 table, right? So we can take this table T1.ibd. Okay. So this is the respective IBD file for the table T1. So we are updating where ID equal to 101. So we need MySQL need to change the value for ID equal to 101. So when I am starting the update statement, what MySQL will do, all the modifications will should be happens in the buffer pool, then it will be flushed to the disk. Okay. So yeah, here you can see we have three structures. One is the in-memory structure and the on-disk structure, and in between you have the operation system also. OS cache also you have between the memory structure and the disk structure, right? Fine. So these all components are reside in the disk, and these all components are reside in the memory. In between, we have the OS cache. Fine. So when I start the update statement, now MySQL need to update the value to name equal to where ID equal to 101. So MySQL will, so this is just time updating one row. This row should be available in the table space, and the table space, there are multiple pages. Any one of the page, this row will be available, will be reside, right? So first MySQL will check when I started that update statement, whether that particular page which contains that row ID equal to 101 is available in the buffer pool or not. 1 second. Okay, sorry. So first it will check that ID equal to 101 page is available in the buffer pool or not. If the page is not available in the buffer pool, then what happens? MySQL will get the page from the t1.ibd from the table space, and it will populate the page in the buffer pool. Okay, fine. So now once the page comes to the buffer pool, then it will modify the value. Set name equal to III. Previously it was BBBB, right? So it will be changed. And once the once the page is modified, that is called a dirty page. Okay. First, MySQL will check the pages exist in the buffer pool or not. If it is not exist in the buffer pool, then it will go to the respective IBD file and it will get the page and it will update in the buffer pool. Then it will do the modification. Once the page is modified, then it is called the dirty page. Okay. So here, when we are doing the modification on that row, still we are not committed. Okay. When we are doing the modification on the row, the same will be modified, will be recorded in the undo log as well. Okay, because MySQL do not aware whether I'm going to commit that change or not, right? In case if I'm roll back, then it should be update the older value, right? The before image of the transaction. So undo log will keep track of it as I show here. Begin that update. You can see this I mean undo log will keep track of the before value. Okay, that is the main purpose of the undo log. Okay, now so the next thing is, so now we are clear about this buffer pool page, data page, and the undo log, right? The next thing is I have different so we know that IBD file will store the data plus index, right? And in case if I am modifying the value in modifying the record, then the secondary index page also needs to be updated. Let's say if I am inserting one value, then the inserting one record, then the secondary index should be appended with that record. In case if I am deleting some rows, then the secondary index needs to be delete that particular entry, the pointers, right, to the primary key. That needs to be removed from the secondary index. In case if I am updating the column which have the secondary index, then that also the second index needs to be updated with the newer value, right? So this needs to be done. But when we are doing this at a same time, when we are updating the data page and the index page at the same time, then it will create some additional load on the DB. To avoid that, we have the change buffer. To avoid that, we have the change buffer. So what change buffer will do? Change buffer will catch the changes to the secondary index. Changes to the secondary index. So whenever those index data will be coming to the buffer pool, that time those records, those index will be merged. That will be merged. Okay, so that is the purpose of the change buffer. So here you can see the same component is available in the system table space as well. Okay, from the MySQL 8.4, change buffer is the major component available in the system table space. So why we have change buffer in memory as well as disk means, in case the MySQL is down, then this change buffer is in the memory, which is in the volatile memory, right? So we will lose this change. So we have the change buffer on the disk as well. But it will not apply to the IBD file on the time when the data comes to the memory, that time it will be updated. So the changes to the secondary indexes will be held in the change buffer. And whenever the index pages comes to the buffer pool, that time this changes will be merged. Okay, so that is the to avoid the high IO pressure, because when we are writing the IBD file and updating the index record on this same time, it will create some random IOPS and it will consume some load on the higher traffic environment. Okay, so to avoid that, we have this change buffer component that will hold the changes to the secondary indexes, and whenever the data comes to the page come to the memory, I mean the buffer pool, that time the changes will be merged. Okay, and now we have done the update statement, and the changes are tracked in the undo logs, and my update, I am updating the name column, which also have the secondary index, right? Secondary index, that is the key column. That changes are holded, I mean, changes are catched in the change buffer. Now, let's assume my MySQL is crash. In this case, what happened? I committed the change in the buffer pool. My transaction is committed. Let's commit it. Okay, my transaction is committed. Just committed. So once I committed in the buffer pool, if the MySQL crash or some any issues like a power failure or whatever happens, what happened? I will lose this transaction, right? Because this transaction is committed in the memory, not yet written in the IBD file, right? So my transaction is committed in the memory. It is not applied in the IBD file. I mean the actual table space file 8. So in this case, if something goes wrong, I will lose my change. I will lose my transaction, right? So to avoid this situation, we have the redo log. Okay, to avoid this situation, we have the redo log. So what is the main purpose of the redo log is crash recoveries. How it will do? So whenever the transaction commits, it will be written in the redo log as well. It will be written in the redo log as well. How it will written? It will written through the log buffer. Okay, the changes will come to the log buffer, and the log buffer will return the uh, transactions to redo log. So here, the log buffer, how this log buffer returns to the redo log, because you can see this log buffer is in the memory area, redo log is in the disk area, on disk area. So in this case, once the transactions comes to the redo log, because redo log is in disk, if the MySQL crash, it will never, we will not lose the transaction because we have the transaction available in the redo log. When you start the MySQL back, it will scan the redo log based on this LSN number, and it will do the crash recovery and it will apply the transaction. But here, writing the transaction from log buffer to redo log, we can control that with the parameter InnoDB underscore flush underscore log underscore at underscore trx underscore commit. InnoDB flush log at transaction commit. Okay, so we have three values for that parameter 0, 1, and 2. So 1 means for each transaction commit, log buffer will write the transaction to the redo log and it will flush it. So this is completely safe. So each transaction commit in the buffer pool, it will be written in the redo log as well. So in case losing the transaction is not possible, right? We are completely safe with this approach. When you have the InnoDB flush log at transaction commit equal to 1, for each transaction, the transaction will be written to the redo log and it will be flushed. But when you have two, for each transaction, log buffer will write the transaction on OS cache. Okay. When you set InnoDB flush logger transaction commit equal to 2, for example, I have the parameter here. Yeah. So InnoDB flush log, this is the parameter. InnoDB flush logger transaction commit. When you have 2, it will write and flush to OS cache. Okay. But coming back to the diagram, it will write and flush to the OS cache, but not in the redo log, not in the redo log. So in this case, what happened? If you have your MySQL crash, then still you can recover the data from your OS cache, right? We can give some little guarantee on that. But if your OS is crashed, if your server itself you are entirely crash or some power issues, then you will lose the data from the OS cache as well. That is also the volatile memory, right? So you will lose the transaction with the, so there is possibility with the InnoDB flush logger transaction commit equal to 2 to lose the transaction. But when you were MySQL crash, then you, you have the chance to get the data back from the OS cache. But if your server itself complete thing is crashed, then you will lose the transaction. When you have 0, InnoDB flush logger transaction commit equal to 0, then what happened? For each second, it will write and flush. So each second means within a second, you may have many transactions, right? Let's say for within a transaction, you may have 1,000 or 10,000 or 1 lakh transactions, multiple transactions you have in a second. So in this case, when you set 0, what happened? For each second, it will write and flush. So in this case, you may lose lot of transactions when you have set it equal to 0. So that is completely unsafe. This is what I'm telling, how this log buffer writing the transaction to the redo log. Okay. Because redo log is important because your transactions are committed in the memory, not yet written in the IBD file. When it is written in this IBD file, then only you are completely safe, right? So when once your MySQL committed the changes on the memory, the same time it will be written in the redo log as well. So how it will written, that you can decide using this parameter, InnoDB flush logger transaction commit parameter. So this is very important parameter. So if you have the OLTP system, then you should make it 1 to achieve the ACID completely. Okay, but having one may impact the performance because for each transaction you are writing and flushing the redo log, right? So you may have spend more IOPS for that. But that is the completely safe setting for your transaction. Okay, fine. So now what happened once the data during the commit, once it is written to the redo log, now you are completely safe in case your MySQL crashes. When you start back the MySQL, you can MySQL D will do trigger the crash recovery on the redo log based on the LSN number, log sequence number, and it will read the further transaction from the last updated LSN number, and it will apply or roll back the transaction from the redo log. Okay, so and what informations will be written in the redo log? That is the next question, right? So redo log, because I have uh, um, one of my friend, he was asking like, does redo log have the SQL statements like bin log? But it is not like that. Redo log will have the changes to the physical file. Okay, it will have the table space ID, page number, and the changes to the I mean the page, which operation, whether it is the update or delete or insert, that operation ID and the changes, what are the changes, how many columns and the newer value, these changes will be exist in the redo log. So we have this pointer, all these things, so that I will try to cover in one detailed video about the redo log. There is a lot of other things to be considered because having the low size of the redo log will negatively impact your performance, or even your transaction may stall. There are the checkpoints, checkpoint age. There are this configuring the redo log is very much important. You should have the proper size of it. So I will try to create one video explaining all of the related stuff. Okay, but in this video, as we are seeing the architecture, now just we need to came to know the purpose of this redo log, right? So now we know that what is the purpose of undo log, and we know this purpose of change buffer and the buffer pool, uh, what is there, and the log buffer and the redo log, right? So the next thing is double write buffer. So here, let me give the quick overview. So we are writing one update on the table T1. What MySQL will do, that where class, that ID equal to 101, that particular row is, first it will check that particular row is available in the buffer pool or not. If the record is, if the page is not available in the buffer pool, then it will go to the table space and it will take the particular page and it will populate in the buffer pool. Okay, so this is what we need to have the good size of buffer pool size, so that you can keep hold more date pages in your buffer pool. And here, if the page is not available in the buffer pool, then it needs to go to table space and get it, right? So you are spending on disk IOPS here, right? So this is what we recommend to have the proper good. The buffer pool size should be good enough to achieve the good performance. Okay, fine. So now once the page is modified, now this page is called as a data page. Okay, and during this modification, undo log will keep track of the old image, so that in case if you are rollbacking the transaction, the older values can be get from the undo table spaces. And now if you're modifying modification have some secondary indexes, the table have some secondary indexes, then those index changes will be captured by the change buffer. It will, so that the particular page when it comes to the buffer pool, it will be merged to avoid to save some disk IOPS. We have this change buffer, and this is also available in the disk inside the IB data one, so that in case the MySQL crash, we will not lose the change. So you can even get it from the IB data one. Okay, and the other thing is redo log. So the main purpose of redo log is when my transaction is committed, if anything goes wrong, I will lose that committed transaction. So what MySQL will do, because yeah, these are in the volatile memory in the RAM part of buffer pool is part of the volatile memory, right? So we will lose that. So to avoid that kind of situation, MySQL will have the val, which is the write ahead logging. So yeah, that is the redo log. So here it will have the transaction. When during the commit, the transaction changes will be written in the redo log as well. Okay. So whenever, in case if your MySQL crash, when you are restarting back, you can get the data from the redo log. And this will be written, the redo log will be written through the log buffer. And for the log buffer, we have that InnoDB flush logger transaction commit parameter 0, 1, 2, we see that, right? Fine. Now, these all things are done. Then when this data from buffer pool, this data pages from buffer pool will be written to the actual IBD file. So that is the next question, right? So we have few flushing, like let's say if you have 10 pages in the 10 data pages in the buffer pool, and if you are gracefully shutting down your MySQL, then all the pages will be data pages will be flushed to your IBD file. And we have parameters InnoDB buffer pool, data pages percentage, and the percentage low watermark LWM. We have two parameters, so we can use that. And MySQL will also do the adaptive flushing. We have different flushing operations that we will see in the separate video. So we have the adaptive flushing and this graceful shutdown and the checkpoint. When you meet the checkpoint, MySQL will flush the data pages to disk very frequently to free some space from the redo log. Okay, so these all things I will cover in the next session. Like when we see about the redo log, that time we will cover these all things. Okay. But now MySQL data pages needs to be flushed to the actual table space file. Then only the record will be removed from the redo log. So because yeah, before writing the data pages to the actual IBD file, read log cannot remove the data, right? Because your changes are currently in the memory. In case something goes wrong, you need to get the data from the read log. So to recover the transaction. So once your data is written, I mean the data pages are flushed to the actual IBD file, then only the data will be removed from the read log. So this is what you can relate this, right? So this is what your read log should have the proper size. If you have a very low number of size, then your read log may be overflow and it will do the frequent flush to the IBD file. And if your system resource not okay with that, then it will signal to stall the transaction. So this we will see in the detail. I will make one video. Maybe the next video I will do that. There we will cover all these things like checkpoint, all these things. Okay, fine. So now coming back to this architecture, when you are dirty pages are writing from buffer pool to IBD file, let's say we see that my InnoDB page size is 16 KB, right? 16 KB. So when this 16 KB page is returning to the IBD file, which is in the disk, let's say my disk block size is 4 KB. So in this case, I need to write 4 blocks, right? 16, 4 into 4, 16. I need to write 4 blocks. So I written 2 blocks, and in between that, in case I have some issues like power issues or some crash happens at the OS level, then this page is partially written, right? This page is not written completely. Let me come again. So I have 16 KB page in my buffer pool, and I need to write on the Linux disk, which is my disk block size is 4 KB. So when I want to write 16 KB, I need to write 4 block in the disk level. Let's assume I written 2 block. I mean my MySQL D written 2 block and 2 blocks are pending, and it started writing on the third block. Suddenly power issue happens in a rare scenario. Then what happened? My page is written partially, right? So in this case, when I'm starting back, this page needs to be corrected, right? So for that, MySQL will maintain the Doublewrite buffer files. Okay. So what happened? Before the 16 KB page, before writing to this actual table space t1.ibd, it will write the Doublewrite buffer first, then it will be written to the t1.ibd. So that in case my page is partial, it can be corrected or recovered using the Doublewrite buffer files. This is the purpose of Doublewrite buffers. Okay, fine. So once it is written in the IBD file, now my change is completely written to the IBD file, and now you can purge the data from the redo log. It will signal the redo log, hey, that transaction I written committed in the table space. Now this redo log will be remove the data from here, and this Doublewrite buffer will also remove the data. Okay, so this is like a high level thing how this architecture is working. So you are writing the transaction, that modification should happen in the buffer pool, and in the buffer pool, if that particular row page is not exist, then it will get the page from the t1.ibd, the table space file, and it will do the modification in the buffer pool. It will update and modify the buffer pool in the buffer pool. Then it is called the dirty page. Then this during the modification, the old before image of your data will be tracked in the undo log, so that if you roll back, your transaction can be corrected. I mean, play the previous value from the undo log. And after you committed the transaction, if you something goes wrong, then you will lose the transaction. To avoid that, MySQL have the redo log. So during the transaction commit, MySQL also keep have the data in the redo log through the log buffer. That will come through the log buffer. So that you can control with the InnoDB flush logger transaction commit. That should be one. We should make it one to maintain the uh, ACID, to maintain the ACID. So this is redo log is exist on the disk. And when this dirty page is written to the actual IBD file, it will write the Doublewrite buffer, then only it will go for the IBD file. In case anything happens partially, then the page partial writes that can be recovered from the Doublewrite buffer. So once the transaction is successfully written in the IBD file, then the data will be truncated from the redo log. And the newer page files will be updated in the Doublewrite buffer, and older page will be also removed from the Doublewrite buffer as well. Okay. So, so here having the small size of redo log will impact the flushing. It will increase the flush rate. So there are many. It will impact your performance very much. So we need to choose the right redo log size. So that we will cover in the next video. Okay. And yeah, few are the other components we did not covered here, which are the adaptive hash index. That is for the reads. If your read pattern is same in the same pattern, if you are reading again and again, then it will convert the B tree search just to the hash, so that it will improve your read performance. So for that situation, you can enable the adaptive hash index. That is part of the read operation. Okay. And if it is not benefit, then I would recommend to disable the adaptive hash index. You will gain some performance boost when you disable it, if it is not helpful, that kind of situation. And this IBT file and the IBTemp file, both are for the temporary table spaces. We have one detailed video explaining this too. This is not part of the transaction. So to understand this temporary table space, I would recommend to see that video which is posted in our channel. There we created this IBTemp1 and IBD file, and when it is growing, when the tables comes to the IBD file, and when it goes to the IBTemp1, this all things are covered in a practical way. So I would recommend to check that video. And this is the general table space. So you can manually create one table space, and there you can attach the different tables. So that is all. This is there you can store the different tables. Maybe if you want to create some tables in the different partition set of tables, then you can use it. This is also the table space files, and this is the file per table, the actual IBD file when MySQL will create when you have the file per table equal to on. If you turn off this, then all the data will be resided in the IB data. So I hope this video helpful to understand the flow. But yeah, this is completely I'm telling based on my understanding. So in case if you see something wrong or you have some comments, please help me in the comment section or directly reach to me. I believe that would be definitely help for my learning as well. And there are few parameters I want to address. So here from the buffer pool related, we know this buffer pool size thing, right? So usually people recommend to have 60 to 70 percentage of your RAM. So yeah, that is good enough, but yeah, it also depends on your data size and hardware thing. So in case if your current buffer pool size is not good fit for your data, then you can consider increase them. And buffer apart from buffer pool also, the thread based buffers, this will consume some memory, so you need to consider that thing also. Considering all these things, you need to choose the proper size for your buffer pool. So yeah, so here we see one example, right? When the update comes for ID 101, if the data page is not exist in the buffer pool, then only it go for the disk. So if your all the transactions are keep doing multiple reads on your disk, then it will create the performance issue, right? When all your transactions are going to disk and some bulk transactions, then it may create some issues, right? So having the buffer good amount of buffer pool size is very much important. We have one video in our channel explaining this buffer pool size and the instances how to calculate. I would recommend to check that video. And yeah, undo lock um, size and maximum size and the number of undo locks. By default you will have two undo locks in the 8.0. And let me check. I can see 4 here, but yeah, that should be okay. ls grep hyphen I undo. Yeah, by default you will have two undo locks. Okay. Uh, undo 001 and undo 002. Previously, these undo locks are part of the IP data one. But yeah, now after we are evolving that MySQL latest releases, we are splitting most of the components from the IP data one for the better manageability and the performance, considering the performance. And the change buffer, you can even turn it off by setting it to none. And by default, the value is all, which means all the changes like inserts, deletes, all these changes will be, the secondary index changes will be catched here. And this InnoDB change buffer maximum size is 25 by default, which means 25% of your buffer pool. Let's say if you have 60 GB buffer pool, then 15 GB of the memory will be considered taken by the change buffer. Okay. So in case if you have very less amount of secondary index just changes, you can consider reducing this parameter. Or maybe if you have lot of secondary indexes, then based on that, you can tune that parameter, but usually do not touch that parameter. But yeah, uh, I don't recommend to increase that percentage, but in case if you have very less amount of secondary indexes, then you can consider reducing that parameter may helpful. And this adaptive hash index, we already see that, right? This is only for major, yeah, this is for the selects. So mostly the selects with equal value with the same pattern, those B-tree searches will be converted as a hashes to speed up the operation. If it is not benefit for your environment, then you can disable that. And redo log, previously we had this InnoDB log file size and InnoDB log files in group. But laterly from MySQL 8, we have the InnoDB redo log capacity. So you will have 32 files. For example, here you can see this where it is. Yeah, InnoDB redo. So there you will have these all are the redo log file. Okay. So yeah, you will have the 32 files for the redo log. So previously we have IB underscore log file 0 and IB underscore log file 1. The two files. And we have this InnoDB log files in group that is by default too. And yeah, in case if you want to increase if you are running before MySQL 8, the 5.7, then you should consider these two parameters, InnoDB log file size and InnoDB log files in group. If you have the latest versions, then you need to consider this parameter. And later versions, you can also modify the redo log without restart. Previously, we need the restart to change the redo log size value. We see this parameter, right? InnoDB flush logger transaction commit. So this is very important parameter for to achieve the ACID. So if your environment is transactional, then on your master node, I mean the primary node, you should enable the parameter with one value for, so that you all your transactions will, each transaction it will write and flush the log file. It will ensure the consistency. Okay. Uh, then yeah, undo logs. I have to return the logs 2 times. Double write buffer. Yeah, you can also disable the double write buffer. I think InnoDB double write equal to off. You can disable that, but we do not recommend that to, because in case if you come to the partial page situation, then you are, if you do not have the double write buffer, then you will be in the corrupted situation, right? So we do not recommend to disable the double write buffer. And also, I think you can disable the redo log as well. But yeah, you should not on your production environment. In case if you are doing some logical load, backing up and restoring somewhere, then on the other non-production systems, if you are restoring that logical backup, then you can consider disable this redo log and the double write buffer. So you will save some IOPS and it will be help to boost up your operations, right? So, and this OS O direct, you can see this. This is the, this will comes with the parameter InnoDB flush method. So using O direct, you can bypass the OS cache. Your MySQL DB will directly write the uh, data from buffer pool to disk. I mean, in the system table space file. It will skip the OS cache. So you, when you are skipping that, you may achieve some little performance, right? Because you are, instead of you are writing here and there, from here to there, you are directly writing from the buffer pool to disk. So that is the one thing. And this is read from the buffer pool to IBD file read. There we have the InnoDB read IO thread parameter. And when you are writing from buffer pool to IBD file, you have the InnoDB write IO thread parameter, right? So yeah, so this is about the high level architecture, and I will definitely uh, create the further videos on the architecture by explaining the each component. We already done for uh, temporary table spaces. I think we have undo, for undo also, we undo table space also we have one, I think. And for the buffer pool, we have one detailed video. So going forward, we will address the redo log mainly with the impact and this flushing, all these things. And we will cover the rest of the components as well, important components as well, we will cover. Okay, so I hope, yeah, this image is from the MySQL official documentation, dev.mysql.com. You can see the link here. So you can directly go to the document and you can refer this diagram. This is very helpful to understand the architecture easily. Okay. And again, if you have any comments or if you feel something I may mistake here, please help us to comment in the video so that everyone will be aware of it. Okay. Yeah, I think, thank you. Um, Same thing, if you like my channel, please subscribe it, and you can share with your friends. And also, I am taking the MySQL course also. If you are interested, you can reach to me. That is the paid course, and I am also selling the videos, the complete course videos. If you are interested, you can reach to me. Yeah, that's it. Thank you. I think this is 49th video in our channel. The next video will be the 50th one. So I will try to, I thought to make this video say 50th, but yeah, it is fine. The next video also, I will try to address the read log from the InnoDB architecture. So that will be my 50th video. Thank you. Thank you for watching. Bye.